Okay, this is problem, it's number 6 on the practice questions, and it's a nice problem because it kind of gives you a hint about how to tackle this, and it's a lot harder if you're staring at the formula sheet to try to figure out the answer than if you're following the lead that you're given about making a graph. So let's take a look at the problem. So it says a commuter train travels between two downtown stations because the stations are only 1 kilometer apart. Okay, diagram. So let's see. So I've got two stations, 1, 2. It's going to travel between these two, and this distance between here is 1.0 kilometers. Right away, I'm going to get rid of that, turn that into meters. So 1 kilometer is 1,000 meters. I don't want to make the mistake of messing up with my standard unit. The engineer minimizes the time t between the two stations by accelerating of a rate of 0.1 meters per second squared for time t1. Okay, well, let's think about it. So we're going to have two legs, right? So I'm going to have one leg, another leg. They're not giving me distance, they're giving me time. So I'm going to call this t1, and I know acceleration at that point, 0.10, and I have t2. They tell me acceleration for the second part is braking at negative 0.5 meters per second squared. Right? So I can guess they're going to spend less time decelerating or have negative acceleration than having positive acceleration. So so this is going to be a bit odd. So part A is sketch a velocity time graph for the motion of the train and explain how each of the numerical values stated in the problem are represented in the graph. This is a hint. This is a hint. So, okay, let's graph velocity versus time. So what's going to happen, right? So it's going to start with 0 velocity, and then it's going to end with 0 velocity. Some point in there is going to have some maximum velocity. I don't know, I'll put it over to the side a little bit because I don't think it's going to be right in the middle of the time frame. And then it has constant acceleration. So constant acceleration is going to be like this, and it's going to have constant deceleration. So it's going to have a line going down like this, right? And remember, so what they're asking you to do, so label all the quantities on the graph. So right, so this is my acceleration for the second part, which is going to be the slope. So this is equal to, right, the rate of change, right, delta v over t. Right? And I can give this more specifically. I can call this, well, what is this? This is going to be, this is going to be my final minus my initial, right? So this is going to be my final, which is 0 minus my initial, whatever max velocity that is. And the time that happens in, I'm going to call that t2. Okay. Let's do the same on this side. Right? So I'm going to get acceleration from this. So this is saying my acceleration is going to be the slope. This is going to be my change in velocity over change in time. I'm going from 0 to v max. This is going to be v max over t1. Okay. So let me clean this up a little bit. So I'm going to, oh, there we go. Let me clean this up a little bit. So I'm going to go put it over here. So the things that we know. So we know acceleration 1 is equal to that. We also know acceleration 1 is equal to v max over t1. And acceleration 2 is equal to negative v max over t2. Okay. Just from the graph. Okay, if you stop there, you're in a world of hurt. So one other thing we need to get out of this, the velocity graph. So the area under the velocity graph tells me displacement, and they've given me a value for displacement. So this is going to be 1,000. So if I find all this area, that's going to be 1,000 meters. Okay. So, well, let me see. Let's break this up. So I'm going to break this up into two triangles, right? So let me see. So the area of this triangle, so area 1, so I'll call this displacement during time frame 1, is going to be the area in here. What's the area of a triangle, which is 1/2 the base, t1, times the height, which is v max. What's this? Well, this is going to be 1/2 my base, or my time frame in here. I'm going to call my base t2, just to make life simpler. So it's 1/2 my base times my height, right? And v max is still my height. So the distance it travels is going to be 1/2 t2 times v max. Okay, so let me transpose this over to the other side so we've got some room to work with stuff. So what we just figured out from the graph is that x1 should be 1/2 of t1 times v max, and x2 is going to be 1/2 t2 times v max. Okay. So these things came from the graph. So really helpful to interpret the graph to get you to equations, right? And now we've got simpler equations. So if you go to the formula sheet and you try to suss it out from the formula sheet, you can get there, but you're going to have to like dealing with quadratics and squares inside of quadratics, and the math just gets really ugly really quickly. So the hint, and they do this a lot. So we'll try to get you thinking in a particular direction, and for a follow-on question, right? Part A, part B, think about what's happening in the first part to help you with the second part. Okay, now we got some math to do. Let me see if I can figure this out. So what do I do? So the other thing they tell me is that I know x1 plus x2 is going to be 1,000 meters. So I'm going to drop the max from the v just because it takes a while to write it. So I'm going to combine these two together, right? So I'm combine. I'm going to say a1 times t1 is equal to my maximum velocity, and a2 times t2 is also equal to my maximum velocity. So I'll set these two equal to each other, get rid of velocity. So I have a relationship, a1 t1 is equal to a2 t2. Does that make sense? Well, sure. So I mean, this is saying the maximum velocity that I reach. Oh, I lost a negative sign here, right? Negative a2, negative. So it's saying that the velocity that I get to is the amount of magnitude of velocity that I have to slow down as well. So it should make sense. I may not plug in numbers yet, but so we know A1, we know A2, but I don't know T1 and T2. So I need a second equation to help me sort that out. So I'm thinking I'm going to go to the second relationship. So this is telling me position. I combine these together. So I'm going to combine these all together and see where it gets us. Right? So let's see. So x1 is going to be 1/2. Let me make sure you can see this. 1/2 t1 times v for x1 plus 1/2 t2 times v, and that's going to equal 1,000 meters. 1,000. Well, yeah, what can I do here? It seems like there should be a simpler way to solve this, right? So I've got two equations and two unknowns. Let's see, can I solve for one of them and plug it into the other? Velocity is kind of a hassle, so let's see if I can get rid of that as well. Let me see. Yeah. Well, let me plug this in. So let me try to get rid of velocity. I'm going to plug in using the T1 here. I'm going to plug in using T2 here. And then I'll end up with two equations and two unknowns, and I can use this relationship then to get down to one unknown. Math. I feel like there's a faster way to do this, but if you see it, go for it. Okay, so let's see. So I'm going to plug this in here. So I'm going to end up having 1/2 a1 t1 squared plus 1/2 negative a2 times t2 squared, and this is equal to 1,000. And I know there's a relationship between these two. Yeah, so I know there's a relationship between these two. So yeah, so let's do this. So T1 is going to be negative A2 T2. Divided by A1. And now I'm going to plug this into here, but I got to square it. So good fun. So I'm going to have 1/2 A1 times this whole thing, which it's going to be negative, so now it's going to be positive. So I'm going to have A2 T2 over A1. I'm going to square the whole thing plus 1/2 negative A2 times T2 squared is equal to 1,000 meters. Okay, well, it's not pretty, but I know everything here, right? So I've got this A1, A2 I know, T2 I don't know, A2 I know here, T2 I don't know, I end up with 1,000. So I don't think I want to simplify it much more. I think I'm just plug numbers in, right? So let me go up to the top here. So what am I going to do? So I'm going to get my calculator out, plug in 1/2 of A1. What was that? A1 is 0.10. I'm going to have negative A2, which was negative 0.5. times T2 squared, T2, well, I'm going to call this T2 squared. I'll square all the stuff inside of here. Divided by A1, which is 0.1 squared. I'm going to add to this 1/2 times negative of 0.5. So I'm going to have 0.5 times T2 squared. And this is going to all be equal to 1,000 meters. Let's see. Now I'm going to get my calculator out. So this is going to cancel with one of these. I have I have a positive 0.5 divided by 1. So I'm going to have 5 squared. So this is going to be 12.5 T2 squared plus a quarter. T2 squared is equal to 1,000 meters. So let's see, so I'm going to end up with 12.75 T2 squared is equal to 1,000 meters. T2 squared is going to be equal to 1,000 divided by 12.75. T2 is going to be equal to root 1,000. Yeah, you can do the math as well as I can at this point. So I'm going to find that, plug it into this relationship to get to my other time, and then I'll know time 1 and time 2, and I got to add them together to find total time. Anyway, hope that's helpful. I'll do the math and post the answer in the comment section so you can find it. Okay, thanks. Bye.